Hello students, today we will be seeing the derivation for a parallel plate capacitor. Okay, so let's start right away. To derive the equation for a parallel plate capacitor, first we need to consider two parallel plates. Okay, consider two parallel plates each having area A. We have to consider two parallel plates and each of them should have an area A and they should be separated by a distance D. As shown. I'm writing it the way you would have to write if you're asked in the exam. And now we have written as shown, so now we have to draw the parallel plates and mark it. So first draw two parallel lines. Okay, so consider two parallel plates and each of this is a parallel plate and this parallel plate has an area A. This is a parallel plate and this also has an area A. And these two parallel plates are separated by a distance D. Okay, and here this I'm taking it as plate 1 and this as plate 2. This is plate 2. This is plate 1. Now we can write plus Q is the charge on plate 1 and minus Q is the charge on plate 2. Plus Q is the charge on plate 1 and minus Q is the charge on plate 2. And we can also write the surface charge densities of the plate are plus sigma and minus sigma. Surface charge density sigma equals Q by A. Surface charge density sigma is equal to Q by A. Now, before we said plus Q is the charge on plate 1. So I'm going to give everywhere plus sign. Okay, this is plus charge here. And minus Q is the charge on plate 2. This plate is having a charge of minus Q. This side is going to be plus because of wait, I'm sorry. And here this side is going to have negative here and it is connected to the earth. Okay, it's an earth conductor. So earthing is done there. So this is how we have to draw the diagram for the derivation. So first we will consider two parallel plates and each of them have an area A and they are separated by a distance D here as shown. And here plus Q is the charge on plate 1 and minus Q is the charge on plate 2, and the surface charge densities of plates are plus q and minus q. We didn't mark them. So this is plus q, this is minus, plus sigma, because surface charge density, right? They are plus sigma and minus sigma. This is how we write. Surface charge density sigma is q by a, charge by area. This we have already studied. Now, what will be the electric field? The electric field between the plates E is equal to sigma by epsilon naught, which is equal to sigma is q by a, right? Q by a, then we'll write this epsilon naught. So q by a epsilon naught. Sigma is surface charge density, and we have written that surface charge density sigma is q by a. Now in place of the sigma, we will substitute q by a. So and then write it together with epsilon naught. So E is equal to q by a epsilon naught. That is the electric field between the planes. Now the potential difference between the plates. The potential difference between the planes, between the plates, in terms of electric field, V, will be E into D, which is E is electric field, D is the distance. Electric field is what? Q by A epsilon naught. So Q by A epsilon naught into D. So QD by A epsilon naught will be the potential difference between the plates in terms of electric field V. Now the major thing, the capacitance. The capacitance C is equal to Q by V is equal to Q by, what was V? V is QD by A epsilon naught. So we can say C is equal to, now this can be written as Q into A epsilon naught by QD. Q get cancelled. A epsilon naught by D. So C is equal to A epsilon naught by D. This is capacitance. Now, if a dielectric, so this is a capacitance for a parallel plate capacitor. Now, if a dielectric medium is inserted, what happens? We will write. If a dielectric medium is inserted between the plates, capacitance Cm means capacitance of the medium will be equal to K epsilon naught A by D, or K A epsilon naught by D. And here K is the dielectric constant. K is the dielectric constant, and dielectric constant, what is K equal to? K is equal to capacitance of the medium by the the Cm is capacitance with capacitance of the medium as the dielectric. C0 is the capacitance with air as dielectric. Cm is capacitance with medium as dielectric, C naught is capacitance with air as dielectric. So this is what you have to write if you're asked to find, if you're asked to derive parallel plate capacitor. First, we will consider two parallel plates. Each will be having area A and they will be separated by a distance of D. And you can write as shown because we are drawing the diagram. Here we will draw two parallel lines, and the first line will be the plate 1, the second one will be the plate 2. Plate 1 is half full of positive charge, and plate 2 is negative charge, and plate 2 is connected to the earth. So earthing is done here. Then show the distance separation. And here, yeah, so you have to write plus q is the charge on plate 1 and minus q is the charge on plate 2. Here the surface and charge densities of the plates 1 and 2 are plus sigma and minus sigma. So, and also write the equation for formula for surface charge density. Sigma is equal to q by a. Now after this we have to find the electric field. Electric field between the plates E. Okay, the electric field between the plates here E is equal to, we know that electric field is sigma by epsilon naught. Here the case of plates, here it is electric field is sigma by epsilon naught. And what is sigma? Sigma is surface charge density. Surface charge density is q by a. We have already written it here. Sigma is q by a. So this is sigma. Now this epsilon naught, we added it here. The potential. So after finding the electric field, we'll go find the potential difference. So we found E, now going for V. The potential difference between the plates in terms of electric field V is equal to E is the electric field into distance. Electric field is what? Q by A epsilon naught. Q by A epsilon naught into D. So that is Q D by A epsilon naught. This is going to be the potential difference between the plates. So we found the electric field between the plates. We found the potential difference between the plates. Now, since we are having E and V, we are going to find the capacitance. Capacitance C is equal to Q by V. Q by V is QD by A epsilon naught. Why did we find here E? E is found so that we can find V. Only if E is there, we can find V. Okay. C is equal to Q by V. V is equal to, we have found it out, QD by epsilon naught. Then Q, when we take the reciprocal, Q, both Q's get cancelled out. This is capacitance is equal to epsilon naught A by D. Yeah, epsilon naught A by D. And here, if a dielectric medium is inserted between the plates, then the capacitance Cm is the capacitance with medium as dielectric. If it is just C naught, then the capacitance with air as dielectric. We should understand that the capacitance, the medium there is air. If a dielectric medium is inserted between the plates, then the capacitance Cm will be K epsilon naught A by D. With this, we just have to add a K. And here K is the dielectric constant. And what is the dielectric constant? A dielectric constant K is Cm by C naught. It is the ratio between capacitance with medium as dielectric and to the capacitance with air as dielectric. Okay, so this is all about the derivation for a parallel plate capacitor. Hope you got it. And this question can be asked for a 3 marks. Okay, this is a 3 marks derivation. It's actually simple, there's nothing much here, right? So that's it for today. See you in the next class. Bye.